Hopefully, this is the session after coffee, so everyone got coffee. This is way better than the session after lunch, when everyone falls asleep. Okay, some of you have tea, but there's caffeine in that too. At least if you got, tea and not green tea or something like that. So hopefully, you'll all manage to stay awake. And hopefully you're all actually going to be able to take something from this presentation. My name is Magnus Hagander. I work for a company called Red Pill Impro. We do actually have, I guess these days, fairly large office here in Gothenburg, but I'm from our Stockholm office. And we're an open source services business all around the Scandinavian region. We're in Norway and Denmark as well. And I lead up our database efforts. And as you might have guessed by now, we focus that on Postgres. Otherwise, I would not be leading it. Within the Postgres team, I am a member of the Postgres core team, so the steering committee for the project. I am technically one of the committers, so I have push access to the central repo. I think in the next version, I have like one patch of 2 lines in it that I pushed myself, but also part author credit for a few tens of thousands of other stuff. But fundamentally I'm there. I work in Postgres Europe, which is our advocacy organization for Europe. And say sometimes if someone makes a Venn diagram of all the different groups in Postgres, I need way too many of those circles. So that's me. Let's talk a little bit about Postgres. Let me just first show who's using Postgres today. Okay, good. So you're in the right room. Good for the rest of you, hopefully you will be using Postgres and we'll give you a good starting points into that. So I named this presentation Postgres Don'ts and Do's. And part of this is basically the experience that I've had as working as a Postgres consultant for 15 years or so. I've seen lots and lots of environments, and it used to be when I got started, only very advanced or early adopters were really using Postgres. These days, Postgres has more or less turned into the default for lots of organizations with new projects. But I've seen lots and lots of different environments over all this time. And I say everybody gets something wrong. Certainly I do. Like every time you set up a new environment, you go like, oh, I'm going to take this shortcut today, and then you regret it, even when you know it. So my goal here today is just take off a couple of the easy ones, a couple of the ones that I see lots of, and that are actually really easy to not do, or to not don't. Anyway, to do the right thing. So I'm going to try to split this up. It's a little mix and match. I'm going to start with a bunch of things that are sort of more on the DBA side, and then I'm going to move over to the things that are a little bit more on the developer side, should you even have that distinction in your organization. So let's do another quick show of hands. Who here would consider themselves mostly a DBA? And mostly a developer. And those of you who put your hand up on mostly a developer, if you've never had to deal with a DBA task, keep your hand up. Yeah. So as we see today, I mean, the distinction between DBA and developer is kind of weird in a lot of ways, and in a lot of organizations today, particularly as we move more to databases like Postgres or environments like our cloud environments, they go into each other, these roles, which I think is generally good because it is an overlapping skill set. So let's start with something important. Can anyone guess what the important thing to start with is? Okay, it's backups. Backups are important. I know you don't necessarily feel that way until you really feel that way. And then you realize how important them are. And what we see today, like a lot of people, when you get started, right, how do you do your backups? Well, hopefully, I'm not even going to ask you who has backups. I'm going to assume you all have them, or at least think you do. The thing that we see a lot of people starting with, right? Postgres has this tool called pgdump, which is what everyone starts without for backups. And it's actually fine, as long as your systems are pretty small. Until it's not. And what I see is a lot of people who continue to do backups with pgdump way beyond when it's reasonable. I've had one client, their backup times, it took them almost 48 hours to take a backup. And like that's not good enough. And usually the real problem is nobody actually cares too much. What I've always used as an example before, it's saying nobody cares how long your backups take as long as they finish in less than 24 hours when you have to take the next one. And then I ran into this customer that took almost 48 hours. Right? They had to move their backups further apart. But it's actually not the time to take backups that's usually the problem. It's when you have to restore them. Right? And if your backups with pgdump take something like 48 hours to restore, it'll take 5 to 6 days to restore. Sorry, if it's 48 hours to backup, it'll probably take 5 to 6 days to restore. I don't know what business would find that acceptable. Right? Which also means, you know, the classic don't actually test your backups, right? Test your restores. And if those take ridiculous time. The other thing that you don't get when you're doing your backups with pgdump is you don't get PITR, as we call it, you know, the point-in-time recovery. If you take backups with pgdump, you take your backup at, I don't know, 1 a.m., and then the system crashes the next evening, and you have to restore all the way back to 1 a.m., and you're stuck. Whereas if you're using PITR, you can use the more advanced functionality in Postgres, and in many other databases as well, to be able to restore until any point during the day. Preferably right before something went wrong, whether it was hardware or software or something, but something went wrong. So pgdump, by the way, pgdump is useful for a whole lot of different things, but it falls out of range for backups fairly quickly, and it's very easy to get started on it when it's fine, and not realize when you've outgrown it. Another thing that we see a lot of backups doing is just using VM snapshots. Right? Pretty much, I'd say 99% of everyone uses a VM today, right? If you're not using a VM, you're using a container in a VM, so you're using a VM, right? VM snapshots are easy and they work, right? Assuming the VM snapshotting system guarantees an atomic snapshot. There is a lot of information out there that says you can't do that, but actually you can. As long as it's guaranteed to be atomic, which many of them are. And what it usually means is they will pause the entire VM for a very, very short period of time. And then they snapshot it, and then they keep running. Right? The big drawback here is it also lacks the ability to do these point-in-time restores. And they can disrupt production. Even, you know, it pauses for a very, very short time, but that in some systems can be enough. That, you know, if something happens and that grows to 10 seconds, and you get a thundering herd problem when it comes back. This certainly can happen. But VM snapshots are a very reasonable way to do backups, again, as you are growing. They'll be way faster and way less disruption than pgdump. But they won't give you the PITR again. You can also use disk snapshots, which has the advantage of not pausing your VM. So they're not actually the same. Far too many people think they're the same. Disk snapshots also works great as long as all of your Postgres data is on the same disk, right? Because being able to do an atomic snapshot across a disk is like the entire reason we have snapshots. So that works. But if you have your Postgres database split amongst multiple disks, and this is like multiple looms in your VM system or whatever, right? For example, if you put your transaction log on a separate disk from the database, then this is not safe. And the trick about it is, it will almost certainly work in all your tests, right? And it will look like it's working in production as well, right? But then you restore, you might get silent corruption. But if all your data is on a single disk, this works great. And again, it's the whole reason we have snapshots. It comes with the same drawback, no PITR as this one, right? But if you snapshot it, and of course, as I'm sure you all know, like disk snapshots can degrade in performance over time, depending on your disk snapshot technology. But that's a question sort of outside of the Postgres realm. Right? It depends on how you're doing your snapshots. So what should you use to do your backups? Really, the easy way from pgdump to something that's faster, in a lot of ways better, is pg-based backup, which is part of Postgres, and it just does a binary backup of your whole database into, for example, a tar file. Right? And if what you need is daily backups or hourly backups or something like that, then this has hugely less overhead than pgdump. And in particular, restores can be many orders of magnitude faster. because the restore from this basically comes down to how fast can you copy files. Right? If you have a fast disk and a fast network, you can copy files really fast. But when you're using pgdump, it rebuilds all the structures. Right? So it takes a lot of time. This will be just a binary copy. And if you want to go all the way to a fully qualified system, PG backrest, which allows you then to do point-in-time restore. It handles larger database. PG-based backup, for example, is single-threaded. If you have a really large database, just pushing that data out may take a long time. If you got to push 10, 20, 30 terabytes out, it takes time. Being able to parallelize this, PG backrest can do that. It deals with large databases, high-performance databases, better than PG-based backup, and it has built-in management of things like, rotating out your old backups, keeping, one weekly and whatever, things like that. Go to one of those. Bonus note, I'm sure many of you have run into these, but we have an enterprise backup system. We have, whatever big, Commvault, net backup, all of these kind of things. And frankly, generally just don't. I have yet to come across one that's actually good. I think the closest one I've probably come across is Veeam. It's less bad than the others. But in general, most of the others, when I've actually had to dig into them, when someone has had a problem, none of them have been good. So my recommendation in these cases really is use either PG-based backup or PG backrest to a disk somewhere, because disk is cheap, and then use your enterprise solution to back up that disk and deal with things like offsite storage and archivals and all of those things we can outsource to this other system, because once we have the output of PG-based backup or the output of PG backrest, they're just files. And when they're just files, that's what these systems are really good at. They know how to do that. So look at those. Okay, moving on to tuning. Who has ever tried to tune a Postgres database? Who felt like they knew what they were doing? Okay. I mean, in fairness, I spend a lot of time tuning Postgres databases, and I'm not sure I know what I'm doing. But I have a bunch of ideas at least. One of the things that I see a lot of people spending a lot of time trying to get the optimal value for shared buffers, because that's the Postgres cache size, right? And in fairness, for most of your workloads, it doesn't matter. You probably need it to be a little, like the rule of thumb things work fine. Like, yes, the defaults are ridiculously low. You need to get them up a little bit, but they're not going to fundamentally change things. Like, they're not going to massively change things. But coming from a non-database side, it feels like the cache really is important to the database, and it is. But if you get this one wrong on Postgres, it will also use the Linux cache, or assuming you're on Linux, the operating system cache, which is much more dynamic. So getting it wrong isn't actually that bad. If you're going to choose a single parameter and spend all your time tuning that parameter, it should be the parameter workman, which controls how much memory Postgres uses for sorting and for hash tables and for operations like that. Shared buffers will, this is for most workloads, right? They'll give you maybe a payoff of 10 to 20%. And workman can give you hundreds and hundreds and thousands of percent, if your workload really doesn't match the original. So if you pick one, pick workman. There are also parameters along wall size and checkpoints. It's not spelled that way, but there is checkpoints. Like, if you have lots of writes, these parameters are interesting. But usually workman as well. There is a little tool on the web called pgtune where you can go in and just input sort of my databases very roughly, like, oh, I have a website and I have this much memory, and it tells you some defaults. For a lot of people, you're getting your 80%, right? You're getting very far by just doing that, if you compare to doing nothing at all. I'll also put in a little, we call it selfless pitch. There is a project out called, or a company called dbtune. The disclaimer is I'm an advisor to them. They're working on machine learning-based tuning for Postgres, where you basically put an agent in, it talks to your Postgres and it measures it and figures out how to optimally tune your workload. And once you get some real load on your database, obviously one of the tricks with tuning is you want to tune before you get the load. dbtune will kick in once you have some load and want to optimize across that load. So if you'd be interested in a tool like that, check out dbtune. It's pretty useful now, and there is new stuff being added all the time. The other thing to look at in Postgres is connections. The basic idea is don't use too many connections. I've never, in 15 to 20 years of doing Postgres, I've never seen anyone tune Postgres with too few connections. Not a single time. I've seen them configure Postgres with too few connections for what the rest of their system is tuned by. But tuning-wise, it's never been too low. It is very common to have them too high. And the number one is don't use too many connections, and to make that happen, don't allow too many connections. This is always a trade-off, but the thing that you have to remember is the way that it works in Postgres, I should say, for every new connection that you allow, you have to give each connection less memory. Because Postgres doesn't have the ability to dynamically size the memory based on how many people are connected right now. You have to size it based on how many can potentially be connected. And if you're then saying, oh, I'm allowing 1,000, but you're only ever using 10, then you'll have to cut your memory configuration by 100. And if you don't, everything looks fine until people start using those connections, and then you run out of memory and crash. And you probably don't want that. So the trick here is that we have to base our tuning on the potential number of connections, not the actual number of connections. And then a little bonus note. Does anyone here use one of the managed services on the hyperscalers, like RDS or Azure, or one of those for your Postgres? Okay. They have terrible defaults for this. Right? Postgres default for max connections is 100. On both Azure and AWS, they tend to go into the thousands. Why do they do that? It's because to change this, you have to restart Postgres. And they want defaults that are painless. They don't necessarily want the defaults that are the best for you from a performance perspective. They want defaults that are painless. And setting it really high is painless because you don't have to restart. But from a tuning perspective, it's a really bad idea. So pretty much every RDS or Azure or similar system that you see, you're going to want to reduce the max connections at least back down to the Postgres defaults. Unless you have a really good reason to go higher. But their reason for going that high is I see their reason, but it's not good performance. And of course, this whole thing ties into the fact that you should always use a connection pool. That's sort of the basics. And you should tune your connection pool, which again usually means fewer connections than you think. But in particular, most connection pools have they have a low watermark. Like as soon as they start up, they open 10 connections to the database. And then maybe they're configured with max of 100. And so you go, oh, I have 5 app servers. Good, that's 50 connections. And you install it and you monitor and you've got your 50 connections and everything's fine. Then you get a load spike. And it starts adding connections because it's going slower. But the problem is at this point, as you're adding the connections, everything runs a little bit slower. So you add some more connections. And at this point, you're up to 500. Well, you're not actually getting up to 500 unless you configure your max connections to allow that. You start hitting hard failures. So the thing that you want to do from a tuning perspective is you want to look at your entire system and say, okay, I have this many connection poolers, this many app servers talking to the system, and you want to make sure that you always have enough capacity on the Postgres server max connections to fit every one of your connection pools hitting the maximum number. And if that number is ridiculously high, then you need fewer connections in your connection pools rather than increasing it on the server side. But there are other things to consider through this. For example, rolling upgrades. I've seen a lot of people getting bit by that. I've even had one customer said you can't use connection pools if you're using Kubernetes. Because every time you do a rolling upgrade, the database crashes. I'm like, I think you're deducting the wrong thing here somewhere, right? Deducing the wrong thing. And the problem there is, of course, during a rolling upgrade, if you have 5 database servers, well, some people would then configure you get 5 of the new version and then kill the old ones, but then you have 10. But even at the lowest number, you would probably at least have 2 of the new one and 5 of the old, and then one by one you move them over, but you want at least 2, so then you have 7. Right? And then when you do your math on how many connections you need to configure Postgres for, you need to configure it for 7, not 5. Right? But it's absolutely compatible with rolling upgrades. In fact, in a lot of ways it makes rolling upgrades better, but you just have to remember that these affect the numbers. Like you get that many more connections to deal with. And again, that can be, it would be really neat if you could like temporarily increase the number of connections and then decrease them again when you're done on Postgres, but you can't. So you have to take room for that. Which leads us directly into, so how do you keep track of these things? How do you monitor these things? And the thing that I unfortunately see too much of is, a lot of people seem to rely on just application monitoring. I've been to a lot of organizations where the only thing that's monitored really is the response time on the website. Like, what's the P99 on the web pages on my website? And I mean, you want that, but you don't want just that. Like, there are too many things involved to go for just that. You want something that actually looks at the database. In how much detail? Well, to the detail that you can understand. And sometimes it's good to also, to some more detail than you can actually understand, because if you have a real problem, you have to bring someone in to help you, and then the data is already there. Which brings us to the second line. Don't assume you know how the database works, and make sure you always have a baseline. Because it's really hard, in some cases, when I come out to a client and they're, we are having performance problems every Tuesday morning. Okay, here's what it looks like. We get this much traffic. Okay, so how did it look last week or the week before? Like, how did it look before the problems occurred? And like, we don't know. If you have to know what it looks like when it works to see what changed. Was it something in the database? Was it just that you had 10 times as many visitors because suddenly your product took off and it's actually a success rather than a failure that your site is getting loaded? So you need a baseline. And then people say, well, what tool do we use to monitor Postgres with? Really, whatever you're familiar with. Right? I don't like the idea of having a separate monitoring tool for every single part of your system. Because if you're monitoring the application using tool X, then monitor Postgres using tool X. All the metrics, all these things that are available in Postgres are available to any tool. Most of the major tools out there today have support for Postgres. To a certain extent. Even if you're a big Oracle shop and use Oracle Enterprise Manager, they can monitor Postgres. Right? Even they can do it. So probably whatever you have can do it. If you don't have anything today, I'd say the most common combination that you'll find today is Prometheus Grafana setups. And there is excellent support. There is a Postgres-specific exporter that will get you the metrics into Prometheus, and then you can do the important thing, which is you can put this together with your application metrics in the same system. So you can see, response time went up, and then at the same time you can see what happened in the database at that time. That's really the important part to get in. Other than that, use whatever tool you know how it works, so that you know how to use it. And just the very simplest of everything, if you haven't done so already, Postgres comes with an extension called pgstat statements. It's shipped with Postgres, it's just not enabled in your database by default. I firmly believe that it should be, so you should just go enable it. What it will do is it will collect statistics about I think the default is 5,000 most common queries. And it will tell you how many times it's been called, how long has it been taking, how many rows has it been doing, how much I/O has it been doing, like all of these things on a per query basis. And in my view, you really need to know that in order to tune your system. And in order to figure out what to do. The reason it's not installed by default is that, yes, of course there is overhead. There is a little bit of overhead to it. I have yet to come across a case where I have not been willing to pay that overhead. It's not a huge overhead, but obviously it's non-zero, and that's why it's not included by default. But I would prefer it to be included, and then I can turn it off if I think the overhead is too much. So that's how I act on all the systems that I interact with. Put it in there, and if it turns out to be a problem, I'll take it out again. And so far, I've never taken it out again. Another classic problem with monitoring is that a lot of people who are not database people go monitor the database, and they have a little graph because it's on all the standard dashboards that shows you how many logs are there in the database. Large number of logs is not a problem. It's normal, it's perfectly fine, happens all the time. For one case, whenever you run pgdump, it will look every single table in your system. But it's a shared log. Right? Multiple people can look the same thing, that's not a problem. And in fact, on a global scale, even a blocking log is not necessarily a problem. A blocking lock means someone's trying to lock something, but they can't because it's already locked by someone else, right? The thing that's actually interesting to look at is blocking sessions. That means there is a query that's trying to run, it's trying to lock something, and it can't, so the query is waiting. What happened there? Did I do that? So the query is waiting. The query is blocking. That's the thing that's interesting. So looking at the locks themselves, that comes later. That's something if we have to figure out why a query is blocking, why a session is blocking. But the first thing, the thing that we want to have on our global dashboards and potentially alert on is, do we have blocking sessions? Are blocking sessions normal? Yes. Blocking sessions are normal. In most cases, they will be very, very short-lived. Because a select will not block an insert, will not block an update, and things like that. But if you have two sessions trying to update the very same row, you will have a blocking session, it'll wait, right? But in particular, if you are doing DDL things, if there are, you're re-indexing something, you're building new tables, those are the things that will generally create blocking sessions that last for a long time. And those should normally not be happening. So if we have sessions that are blocking for a long time, what's a long time? Depends on your system, right? But in your typical web system, a long time is probably, 10 seconds or more. If they're blocking longer than that, then it's at least worth investigating and seeing why this is happening. There are a couple of other things that are worth looking at. For example, you have a lot of sessions, right? You have session state, they can be active, they can be blocking, they can be idle. Idle sessions are not a problem. Idle sessions are perfectly normal, particularly when we're using a connection pooler. We will always have idle sessions. That's one of the points of the connection pooler, right? So don't go killing off all your idle sessions. There's also a state called idle in transaction sessions. And those are a red flag. That's a session that has opened a transaction, started doing something, and then became idle. Now, the mere existence of them is not a problem, because every single transaction that does more than one thing will go into idle in transaction. Right? I do begin, I run a select, and then I run an update. Well, between the select and the update, the session will be an idle in transaction. It'll probably only be there for milliseconds, but if you just snapshot, look at all my sessions, you go like, oh no, I have 3 idle in transaction sessions. That's fine. The thing that's worth looking at is if they have been idle in transaction for a longer period of time. Because that means that they did something and then they stopped. And that should normally not happen. Right? In the way that we build systems today, we don't open a transaction and then let the user sit for an hour filling out things and then finish the transaction. Like, that's not how we do it. If your system does that, you probably need to change your system to get good scalability. Right? So monitoring for idle and transaction sessions that are sitting around for a long time, they usually indicate either an application bug. Right? I've seen plenty of those. Or it's just a DBA or a developer or a statistician or something who started doing something and then went to lunch. Or even worse, went on vacation. Left their computer running with an open transaction. Right? Those are not normal things to do. So some things to help. Other than monitoring, we can also help with these by setting appropriate timeouts on the database side. None of these timeouts are set by default, and they're those like they can help you a lot by adjusting them fairly little. There's something called an idle session timeout. It's, as I say, usually only useful if you don't have connection pooling. Otherwise, it'll start killing off your connection pools. And we just said you should have connection pooling. So maybe not focus on idle session timeout. Then we have named by committee idle in transaction session timeout. Say that fast 5 times. It's a terrible name for a parameter, but it is really useful. Right? It tells you how long is a session allowed to stay in idle in transaction state. So it's not the length of a transaction that's in this state, it's how long has it been in this state. And for a lot of applications, this can be set pretty aggressively. Right? Because normally, and by aggressively I say, set it to a minute or 2. Right? At that point, it is not going to be affecting your other parts of the system, but it's also very unlikely to actually affect your application, because if it's stuck there, it's probably already broken. Obviously, you'll have to see for your specific application, And you'll have to look in your log files and see if this fires, and then figure out why. Don't just leave it at that. And finally, there is also a transaction timeout, which can be useful. So this is how long is an entire transaction allowed to be, regardless of whether it's doing something or not. A classic setting for this is, well, I have a web app. My web server times out all requests after 2 minutes. But if your transaction starts firing things on Postgres and it fires off a 5-minute query, Postgres doesn't know that your web server has already timed this out and will never deliver the response to the end user. So if you have a web server application server that has an explicit timeout of, say, 2 minutes, then you can set this to 3 minutes. Because at that point, you know that nobody's going to read this result. So you might as well kill it. Otherwise, we keep running for no reason. All of these sessions, all of these parameters can be set on a per-user basis. So if you have a mixed workload system, you might have a web server, but then you might also have some analysts running queries or some reporting queries and stuff running. Then you probably don't want to set the transaction timeout on those. And you don't want to set transaction timeout on your PG dump if you're using PG dump, because then your backups will time out and die. We don't want that. But you can set it specifically on the user that's running the web application. And just sort of get in ahead of the problem even showing up. Again, idle session timeout, there are use cases for it, but most of the time we are using connection pools, which kind of disqualifies it. But the other two, I tend to try to set on most systems that I'm working with. And you can set them pretty high. Right? Again, if you have an idling transaction, you can set it to 24 hours. Right? You sure are not supposed to have them running. Like, don't set it too close. Even at very high numbers, it can solve a lot of real problems when the problems are caused by an application bug that just keeps things running. Okay, moving over from tuning. Let's talk a little bit about security. Number one, stop using MD5 for passwords, please. I mean, it's been the default for Postgres until fairly recently for backwards compatibility, but we have supported Scram SHA-256 since 2017. It's been in every supported version of Postgres for 4 years or something now. Like, there's really no excuse not to stop using MD5. And the funny thing is, the Postgres MD5 support, the problem isn't even the fact that the MD5 is MD5. Right? Because MD5 for password is not as bad as it sounds. But the Postgres implementation of the protocol around the MD5 is bad. Whereas the new one uses both SHA-256, which is quite safe, and Scram, which is a proper challenge response protocol between the client and the server. The only thing to remember here is, yes, you need to upgrade your clients as well to a version from at least 2017 or 2018. You probably need to do that anyway. And if you're using a, I don't know, JDBC driver from 2015, well, you want to look at upgrading that regardless of this. And once you've done that, just do it. And the Postgres defaults have changed, but if you keep upgrading Postgres, it'll copy the old settings, and it keeps working. Postgres version 18 that's out now will actually start warning you about using MD5. You'll get lots and lots of log entries saying, hey, you should be using MD5. You can turn those off. Don't do that. Turn off MD5 instead. Much better. Use TLS encryption only if you actually need it. Right? There is a non-trivial overhead. With TLS, the classic is like the real thing is new connections are expensive. Like once you're connected, sending data is not super expensive to encrypt, but new connections, especially then if you're not using a connection pooler, can get substantially more expensive. And on some distributions, the default is to use TLS encryption over localhost. Like if you don't trust your localhost, you have a bigger problem. Right? TLS will not solve this problem. And it turns out that PKI, if you're going to do it right, is like hard. You need to do all this certificate and CAs and distribute CRLs and all that stuff. If you need it, you should absolutely do it. It's there, it works, it's great. But if you don't need it, then don't spend effort on it. And just turning that off can make your system run much faster. Again, depends on what your requirements are. If your application has local users connecting directly to it or connecting with pgadmin or dbeaver or something like that, look into using Kerberos and GSS API for your authentication. It's much easier than it used to be. Like 10 years ago, this could be painful. particularly in Active Directory environments, which happens to be the by far most common deployment of Kerberos, certainly outside of academia. But Microsoft have changed the defaults to be much more compatible with everyone and everything. So it's not particularly hard these days. And it gives you true login security, true single sign-on, not just a reused password, but actual ticket-based sign-on. And if you have this, you can turn on encryption at that layer and you don't have to deal with PKI. They already dealt with it for you within the Kerberos realm. So look into it if you have that. It is not a great idea if what you have is a web app. Right? Then you don't want to use that between the web app and Postgres. You might want to use it from the end user to the web app. And one final DBA note. Don't panic about vacuum. Like everyone, once your system becomes really successful and you get millions of customers or whatever, yeah, you're gonna have to deal with vacuum, right? But I see far too many people spending far too much time dealing with their vacuum well before they need to. Like you used to have to do 20 years ago in Postgres. But it deals with a lot of scenarios just out of the box, perfectly fine. Are there optimizations to be done? Yeah. But there are other optimizations that are worth much more to you until you get pretty far into your use cases. It's when you start having loads of updates and deletes, basically, you may have to start poking at it. But there are so many other things that you need to poke at first. Okay, let's switch over and talk a little bit about the more developer-focused side of things. I noticed more of you put your hands up on developer, but then you said you also had to deal with the DBA stuff because you didn't have a DBA. Let's talk data types, because this shows a lot of classic problem. Who's ever heard of a UUID? Yeah, who loves them, right? It's like, there's the good, the bad, and the ugly, right? UUIDs have excellent properties, and they have terrible properties. Should you use them? Maybe. It really depends, right? The basics is, using an integer or a big int will be faster, period. Every time. If all you need is a unique key, it's unbeatable, right? Because they map directly to your CPU registers, they're implemented fully there, they're aligned with the memory alignment, like 64-bit integer versus a 64-bit CPU. UUIDs are, number one, they're 128 bits. We don't really have 128-bit CPUs. And they're formatted in a weird-ass format on input and output. But fundamental. They bring, the real big problem that they tend to bring to a database system like Postgres is write amplification. Because every time, if you have your typical primary key integer, right, it starts at 1, and then you get 2, and then you get 3, and then you get 4, you kind of get the point, right? Whereas the whole point of UUIDs is that they go all over the place. So you don't, in a 1, 2, 3, 4 scenario, you get this nice linear table with no fragmentation and a beautifully built index. And a fully random UUID tends to very quickly, like every time you insert, it actually has to put it somewhere else, and it has to split pages and do also like rebalance the tree all the time, which means that what you thought was a small right is not a small right. If you're inserting into a table that has an integer key, like at least, 100 inserts will go on the same disk block. And we'll need to write that disk block once. With UUIDs, it's more likely to go on 100 separate disk blocks and have to write 100 times. Right? This is a very real cost in UUIDs. They also bring good things. Right? There are things where we need them. For example, we might use them to have an external identifier that we want to publish that we don't want people to be able to guess. I'm sure we've all seen the systems where you get a link back and the secret link has a number in it. And you just add 1 to that number and you get a different customer. Like, don't do that. If that's what you're doing, UUIDs are for that. So when we want to use UUIDs, because again, there are many good use cases for them, then, well, first of all, in the database, there is a UUID data type. Use that. Don't store them as strings. For one thing, the UUID data type will actually internally store them as a 128-bit integer, and you can interact with them as strings. And in your application, if you have a proper Postgres driver, whether it's your Java driver or your Go driver or Rust driver or whatever, it'll map natively, it'll transfer it in binary. But you can interact with it as a string manually as well. And consider using UUID version 7, which is another one of my favorites because there are 7 versions of UUID and they're all the same. Because the definition of UUID version 7 is you create the UUID in a different way. And so is UUID version 6 and 5 and 4 and 3. Right? UUID v4, I think, is the normal, completely random one. The thing that UUID version 7 does is it splits the UUID up and says the beginning of it is actually going to be time-based and increasing. And the rest of it is going to be fully random. So you reduce the randomness a little bit. It's still, I don't know, I think it's still like 90 plus bits of random. But you get rid of a lot of this write amplification because the actual UUIDs as generated will be in order. The first part will be in order, that's the part that really matters. So they can help a lot with this. But of course, this may not even be a Postgres thing. So Postgres supports UUID version 7 since last year, I think it is, or maybe a year before. But you might be generating the UUIDs in your application, in which case you could have supported this for a long time, long before UUID v7 was even official. Right? And you can change it in the application because the actual UUID is the same. There's no change in the UUID itself. Classic problem, should I use integer or big int, as they're called in the SQL standard, int4 or int8, as they're called in Postgres, which is 32 or 64-bit. There's also a small int, which is 16 bits, but let's ignore that for the moment and say, should I use 32 or 64-bit integers? And my answer is basically, if there is a risk or chance, depending on what your business looks like, that 32 bits will at some point not be enough, then use 64 bits. Right? But if, for example, this is the counter in your table of customers, are you likely to ever have 2 billion customers? Probably not. 32 bits kind of reasonable there. If it is orders, well, you know, if you're really successful, you might get to 2 billion orders. And if it's order lines, you can really get there, right? Not unless you're successful, but it's really annoying when you get successful and then you hit this. I've had a couple of customers who've had exactly that problem. And the problem is also when you hit this, it's because you're taking a lot of traffic. So you can't just shut things down and change. And changing from 32 to 64-bit is a very painful operation. It is okay if it's only in one table. But usually what happens here is these are things that have foreign keys left and right to multiple tables. And dealing with that and changing the data types, it's really painful. So if you feel like the overhead of using a 64-bit number from the beginning is very low, don't optimize that if you think there is a risk/chance that you will get past the 32 bits. And remember, in Postgres, these are signed. So it's really 31 bits if you're starting from 0 and up. Another classic problem, don't do enums as a string. Right? If you have a field that has state or status, right? And it really has 5 values, and you store each one of them as a string on every row and 100 million copies. That is really, really inefficient. For one thing, there is storage overhead. They take more space. And there is also processing overhead. Because strings are not as simple as you think. In fact, if you look into things like locale-aware sorting and locale-aware things, like, you don't do that, really. Like, leave that to somebody else. It's incredibly complicated. And by default, that's how all strings are handled, whether you need to or not. If you're using enum, it is stored and processed as an integer, as a 32-bit integer, by the way. If you have a set of values that almost never changes, such as the order status, right? Then enums are great. If you have a set of values where you keep adding things on a regular basis, then you probably want a separate table and a foreign key. The step to go there comes pretty quickly. But a Postgres enum is really efficient if you just have a couple of statuses and they pretty much never change. And for those of you who haven't seen it, this is how you create and use enums in Postgres. So basically you create a type called status in this case as enum, which can have 3 possible values. And then you can just use that as your data type when you're creating a table. And when you interact with this table, you put in the values initial, processing, and done. Internally, they will be 3 integers and you don't know what they are. You can add to an enum. You can add more values to it, but you can never remove a value. Why not, you ask? Well, because doing that would require revalidating all your data in all your tables to make sure that this value doesn't exist anywhere. And Postgres just doesn't do that for you. But you can add. And if you need to restrict, say this is not allowed anymore, then you can still use the same enum and add a check constraint that says you're not allowed to use one of the values that's still in the enum. And Postgres will be able to verify that for you and enforce it. If you're dealing with ranges of data, don't store them in separate columns. What do I mean by ranges of data? Combinations of start and stop. Right? You have typical integers or timestamps, for example, like this thing starts on this day and ends on this day. Postgres has native range types. Use those. Right? They're easier, you get your querying easier, particularly when they start to get a little bit more advanced. It has full index support. It has exclusion supports where you can say there can be no overlapping ranges, for example, in my table. Just like you have a unique constraint to say there can be no overlapping integers, you can say there can be no overlapping time ranges in this table, for example. You get all of that for free if you use a range type. So again, a quick example of what that would look like. There is a range type called date range. It's built into Postgres. You can build your own range types too. But the built-in ones include date range. Then you say I have an insert into my table, and this is just the syntax that's used for a date range. The square bracket indicates an inclusive range, and the right-hand regular bracket indicates an exclusive range. So this range includes the 26th, but does not include the 27th. This can become even more interesting when you're starting to add timestamp with timestamps. You get times as well into it, so you can have an exact number. Okay? And then when you query it, you use this cute-looking at greater than operator that just says, give me all the rows where the current date fits within this range. Say, well, this is not that hard. Like I could write that, and I could just say where start date greater than this and end date less than this, right? But it gets really interesting when you start saying, well, what if I want to find two ranges that overlap each other? And you have to write that. It gets to be lots of ands and ors, especially if you start allowing things like, it can be an unbounded range. It goes from today until forever, or from forever until it's valid until this day. So there is a separate operator, the double ampersand operator, which will do overlaps. And then you start combining those things. The queries become so much easier when you're using the range types. Again, this is one syntax. You can also, there's a function called date range that just takes two dates and creates a range. So you don't have to use this convoluted syntax. Some client drivers will map this into range things on the client side as well. So if you're dealing with start and stop values, just do this. Who has ever done pagination? Click next. We've all done that, right? The classic thing here is avoid doing offset pagination. Just in general. What's offset pagination? This is offset pagination. Right? You select something and then you say order by the date field here, and they say limit 100 offset 300. I'm on page 3. Right? And then I click next, and it'll be limit 100 offset 400. And then the limit offset 500. The problem is to get to this one, it has to actually scan the first 300 rows and then give you 100. And if you're at offset 1000, it will scan 1000 rows to give you 100. Or it will scan 1100 rows to give you 100. So instead of this, look into always using what is generally referred to as key set pagination, because then you can use an index. You need to put a where clause in there. You need to put the value in there. You need to pass, in this case, this date value or the time value in as a parameter. Instead of saying page 3, you say page starting at this date. And suddenly you have an index, and this will be fast no matter how many times the user clicks ahead in it. On the topic of query generations, ORMs, right? Yeah, I'm a database person. You all know what I'm going to say, right? The thing here really is, like, ORMs, the selling argument for a lot of ORMs is to be generic. Like, you can change your database and don't change the application. Well, number one, you can't. Like, it doesn't work that way. They don't actually fully solve that problem. You still have to do database update. And also, in fairness, most of the people I work with change their ORM twice as often as they change their database, or 10 times as often as they change their database. It doesn't actually solve that problem. And often, keeps you away from using the power of your platform, whether that platform is Postgres or a different database. So does that mean don't use ORMs? Well, no. Just use ORMs the right way. ORMs are excellent for things like entity management, like I want to edit this one object, I want to map this one thing. Like doing stuff like that, ORMs are really good. You just need an ORM that supports these things like range types and UUIDs and doing those the right way, but a lot of them support that today. The thing is, you just can't use ORMs for everything. A lot of things, ORMs today are pretty smart, but they're not that smart. And don't be afraid of breaking out the SQL when you really need it. Which brings me to the last round of a couple of things. Obviously, you can spend a lot of time learning everything about SQL. That'd be great. I would like to have time to do that myself. There's lots of stuff to do there, right? But learn some of the things that are beyond basics. They don't even need to be the really advanced stuff. Maybe it does. Sometimes it does. But maybe go there when you really need it. When you go, hey, this feels like something that maybe someone else did before. And if they did, it's quite likely it's actually in SQL somewhere. And the things here, most of the things that I'm going to show you now, just a couple of examples, I'm not going to go through them in detail, just to give you a pointer, are things that are in the SQL standards. They're not necessarily Postgres features. They're everyone's features. Of course, I'm going to start with one that is Postgres feature, and that is returning. And it really goes into the avoid running multiple queries. Okay, I'm sure everyone has at some point written something that does, this. Insert the data, and then you have to query the data back to get the auto-generated ID that came from this data, right? And that's one of those, like, just don't do that. Postgres has the returning clause, which says insert it, and then return the data from that insert as if it was a select. Also applies to updates. So if you update 100 rows, you'll get 100 rows of sort of virtual select data coming back. And you get it as a single query. You save a round trip across the network, a round trip into the Postgres planner, and a round trip of the execution. And whatever comes out of returning is a standard Postgres result set, so you can use it into more advanced queries. You could create a CTE that does insert into blah blah returning, and then take the result of that and join it to something else in your result. Okay. Same thing if you update a bunch of rows, join it to something else or query it as it comes out of the returning. So this one is Postgres specific, but it's been around in Postgres for 20 years or more. And it can help you, makes a lot of things easier and also a lot more efficient. Another thing that I find a lot of people don't know about is filter aggregates, which allows you to aggregate across subsets in a single query. Okay, the typical aggregate, right, is when you do a select company, comma, count star from a table, and then group by company. Gives you an aggregate per value. But what you can add is for each individual aggregate, you can add a where clause. So in this example here, we're selecting company, and then we're count star, filter where active. So do the count star, but only for the rows where the column active is true. And then do the count star only for the rows where the column active is false. And then do the sum amount only for the rows where the column active is true. And it will scan the table once. It'll group the table once. It'll return all these rows at once. I see a lot of people will run this. I mean, obviously this is a doctored query, right? But we'll do this as 3 separate queries. Running it as one query will be at least 3 times as fast. Probably not more than 3, but sometimes more than 3 times as fast. But it will be much better. Another thing that far too few people know about that is also pretty easy to use is something called window aggregates, which is aggregates against, that's supposed to say partitions. Aggregate against partitions without grouping. I want all the data, but then I want some things that are actually based on groups of the data. So here's an example of that. I'm selecting a name. So in this case, it's the name of each person here, and it's saying, well, the count star over partition by company, which means for each name, I will get the number of entries with the same company. Next one, rank over partition, which within the company that I'm in, what's my order if it's ordered by amount? I'm number 1 or 2 or 3 or 4 in the list. And the final one, which shows the example of amount minus lag amount, which is how much does my amount differ from the previous value within my company. So you basically partition the data out, and you can access like rows up and down from it, but you get one row for each row in the table. Then of course I can add another where clause on the table, in which case it'll reduce it down to those, but it'll let me calculate all of these things in a single query, which means in a single scan of the table, whether it's an index scan or it's a sequential scan. And that really brings into a lot of this. The queries, the TLDR version is run fewer queries. Pretty much anything is better, almost every case. Obviously there are exceptions, a little asterisk, and we'll write that in small print at the bottom. But in general, if you can write it as a single query, it's almost guaranteed to be faster than if you're writing it as multiple queries. I've seen pages, I've written 60, 70, 80 line long queries that are still way faster than two simple queries. Especially if one of those queries is running a loop. Right? That's the classic. You run a query, and then based on that result, you run more than one more query. Right? Almost every case where you do that, see if you can write that as a single query. It will almost certainly be faster. Asterisk, maybe not always, but almost. So look into those, especially if these loops are being done in the application. Keeping the processing close to the data tends to make things faster, pretty much everywhere. So with that, I'm going to wrap up with a summary that basically says, by doing just a couple of small things like this, you can get much better out of your database, you can get much better out of your application. You don't have to spend 2 years learning advanced SQL. A lot of these things are fairly simple. You need to read up on them. You can get pretty far. The Postgres defaults are often suboptimal, both the configuration and also again the methods that we interact with it. A lot of the time because we don't know. We don't realize how much the database can actually do for us. And it is usually worth looking into it. It'll keep your application chugging along much longer when you do get successful and get those billion customers that we all hope to get. And with that, thank you very much.
Thank you. I think we have time for maybe one question. I see a hand.
I checked the PG Backrest website, and it has a notice of obsolescence.
Yes.
Do you have any other recommendations?
So first of all, that notice came up like today, or maybe it was yesterday. I still recommend PG Backrest at this point. We will see exactly what happens. It's basically the maintainer, for others, the maintainer of PG Backrest has said he's failed to find a new employer that will let him work on PG Backrest enough. So it has been declared as obsolescent. He's also said if somebody wants to fork it, they just have to change the name. So my personal hope would be that someone actually figures out a way for him to continue working on it. But as a second choice, I would hope that someone forks it and takes it from there. It is used across so many organizations that I think it's a pretty strong chance that someone somewhere will pick that up. And until then, yeah, I am not stressing to replace my PG Backrests for a long time. It's there, it's been working really well. I'd stick to it until we know for sure what happens down the road with it.
Perfect. And with that, thank you again.
Thank you.